Hey, this is Horner. We're going to look at the 2002 AP Physics 1 question. You've got a cart and it's going 3 meters per second. It is a 2 kilogram cart and it collides with this other cart which has a mass that we don't know and it's m. The original contact is made at 0, and if you were to plot this contact or the force between the two carts, you'd see they get really big, and then after the carts get done colliding, it would go back down to 0 again. And that whole thing takes 0.5, I'm sorry, it takes 1 millisecond. Remember, milli is equal to 10 to the negative third, and kilo here is equal to 10 to the positive third. So the maximum here that we have is 10 times 10 to the third, and then it looks like with the two triangles that we have here, one of the triangles would be 0 to 0.5 milliseconds and from 0.5 to 1 millisecond. So we're going to do some things here to help us with this problem. The first thing that we need to do is we need to find out and just kind of remember and state that impulse, so remember J is impulse, is equal to the change in momentum. And if I want the change in momentum, I can find that easily by just taking the force and finding the change in time. So I just use my maximum force, which is 10, and then I need to find the change in time. But we've got to be careful because this is not a right triangle. We actually need to find the area of the entire thing. But to do that, we need to find the area of each one of these triangles. Notice that this triangle is the same on both sides. So to do that, we're just going to say delta P is equal to the area of one of the triangles times the area of the second triangle. So I'm sorry, just add the two. But because they're the same area, we can just multiply. So we're going to say 2 times 1/2 of the base, and notice the base is 0.5 times 10 to the negative third seconds, and then we do the height, and the height of this is 10 times 10 to the third newtons. So when you're done, your change of momentum is 5 newtons times a second. So the system goes through a basically goes through a collision, and our change momentum is 5 newtons times a second. So let's go ahead and we need to find out what is the momentum of the second cart um, the momentum of the 2 kilogram cart after the collision. So the 2 kilogram cart, so we're going to put P 2 kilogram, and then we'll just write after the collision. So the 2 kilogram cart after the collision, we know that its mass is 2, we know its velocity is 3, and what we'll do here is we're going to subtract off the 5 Newton seconds that we just got. So we know that this was the total. This is what we have for the 2 kilogram cart. So let's see what we have left. So we're going to say 3 times 2 is 6, minus 5 is going to give us 1 Newton times a second. Um, the other thing we can do is we can say, let's find out what the velocity of this cart is afterwards. So we know the momentum of the 2 kilogram cart after the collision is equal to the 2 kilogram cart times the velocity after the collision. So this is the velocity of the 2 kilogram cart after the collision, and that's equal to 1 Newton times a second. So we're really just looking at this. We want to find out what is the magnitude and direction of the velocity of the 2 kilogram cart. So now we're going to be able to find it. So the velocity of the 2 kilogram cart after the collision is equal to 0.5 meters per second. And we know that it's also to the right because it is still a positive number. So we had our momentum before, which was 3 times 2, minus the change in momentum, and that gives us our momentum after. And now, since we know the momentum after, we can say that momentum after is equal to the mass times the velocity of that cart after, and we find out that that cart is moving at 0.5 meters per second to the right. So for this whole thing, you're going to end up with 4 points. You get 1 point, I'm going to do this in blue, you get 1 point for just stating this equation. You get 1 point for finding the area. You get another point for doing this step. to find out what the momentum is after, and then finally you get a point for finding out what is the speed of the car, the velocity of the car afterwards, but you have to make sure that you include the direction because that was asked for in the problem. The next part of the problem is letter B. They want us to go ahead and find the mass of the second cart. So now that we're going to find the mass of the second cart, we know that the momentum of the 2 kilogram cart, okay, before the collision should be equal to the momentum of the 2 kilogram cart after the collision plus the momentum of the unknown mass cart after the collision. So the 2 kilogram cart before we said was 6 newtons times a second. We got that from the 3 times the 2. And then that's equal to the momentum of the 2 kilogram cart after. So that would be 1 newton times a second plus the mass of the second cart times its speed. And its speed afterwards we said was 1.6 meters per second. And if we look back up at the problem, it tells us that the second cart acquired a speed of 1.6 meters per second to the right. So that's where we came up with that 1.6 meters per second. Now that we have all these numbers, we can go ahead and do our math and find out what the mass is. So 6 minus 1 would be 5 is equal to the mass times 1.6 meters per second. And so our mass here is just 5 divided by 1.6, and that would give us 3.1 kilograms. And that's the mass of the second cart. So question is, how many points is that worth? That's actually worth 3 points. You get 1 for the statement, you get 1 for the statement that the momentum is conserved. So the momentum before should be equal to the momentum after. You get 1 point for plugging everything in correctly and 1 point for the correct answer. After the collision, the second cart eventually experiences a ramp, which it traverses, and all that means is it just travels along the ramp with no friction. The graph below shows the speed of the cart as a function of time for the next 5 seconds, where t0 is now the instant which the carts separate. So this is an inelastic collision. I'm sorry, it's an elastic collision because they did separate. Notice that the speed of the cart is 1.6, and then when it gets to the ramp, it slows down from the 1.6 to about 1/2 of a meter per second. So at this point, we know that the cart must be going up a ramp, and that's the only way for it to lose any speed. So they want us to calculate the acceleration of the cart at 3 seconds. And to find the acceleration of the cart is really simple. If you remember back to when we were talking about position, velocity, and acceleration, the slope of a velocity versus time curve gives us acceleration. So we want to know what is the slope. So the acceleration here is equal to the slope of the line. So to find the slope of the line is pretty easy to do here. I think the easiest thing to do is just to say the acceleration is equal to, and we need to do our final, so this is about 0.5 minus, and we said that it's 1.6 for the y-axis, and we're going to divide that by, this is 3.5 seconds right here, so that's our final time, minus 2 seconds, and when you're done you should get an acceleration of negative 0.73 meters per second squared. So just trying to find acceleration is all we're doing in this problem for that part of the problem. For letter D, it says calculate the distance traveled by the second cart during the 5-second interval. So here we're looking at this entire time. We want to know how far did it go. And if you remember from what we did way back in first trimester, if I can find the area underneath all of this, then we will find out what the distance is that it travels. So let's go ahead and try to figure out what that distance would be. First thing I need to do is just separate it, and we're going to separate it into 3 things. We're going to separate it into this box right here. So we've got the blue box. Then we're going to separate it into this trapezoid, which looks like this. And then the last thing we're going to do is we're going to look at the little rectangle that we have here. You can do it that way. There's a lot of different ways to do it. I think this is probably the easiest. So let's do the blue box first. So for the blue box, we've got 2 seconds times 1.6, and 2 times 1.6 is going to give us 3.2. So this box right here is 3.2 meters. The next thing we need to do is look at this distance. That'll be the second distance. And if I want to know what is the area of this trapezoid, I'm just going to take my my height here, which is this segment. Okay, I'm going to add it to the height on the other side. I'm going to divide that by 2, and then I'm going to multiply by the base. So this one is just basically the 2 parallel sides, so that'd be 1.6 plus 0.5 meters per second. We're going to divide that by 2, and then we're going to multiply by the time that it took, which is 1.5 seconds. The other thing you can do is make a little triangle here, find the area of that triangle, and then find the area of the rectangle underneath and add them. I just find this to be a little bit easier to do. So this is equal to 1.6 meters. So now I know this is 1.6 meters. And then finally I'm going to take 0.5, which is this height, times our box here, which is somewhere around another 1.5 or so seconds. And so I'm going to do that math down here. 0.5 meters per second times 1.5 seconds, and that's going to give me a distance of 0.8 meters, and that's this little box right here is 0.8 meters. So now we just need to add all of them together. So we're going to take 3.2 plus 1.6 plus 0.8, and we will end up with 5.5 meters, and that is the distance that it travels. The very last thing that they want us to do, and we've already really done it, is it says state whether the ramp goes up or down and calculate the maximum elevation reached by the second cart during that 5-second interval. So we know that the ramp is up, the ramp goes up because it slows down, and then they want us to go through and try to figure out what is the height. So for this one, we're going to use our good friend, the conservation of energy. So I know that the mass times gravity times height. So here is our ramp. Here's the height of the ramp. So we know that from here to here is the height. And the energy due to the height is potential energy. And we know that it is going from this point to this point. Our original speed here is equal to 1.6 meters per second. Our final speed is 0.5 meters per second. And so what I'm going to do is I'm going to say this is equal to 1/2 of the mass times the original speed squared minus the final speed squared. And that will be our 1/2 mv squared. So let's go ahead and solve for the height. We can cross off the m's, and now we're left with the height is equal to 1 over 2 times, and then this is the gravity, which is 10, and we need to now take it times 1.6 squared minus 0.5 squared. And so if you do all your math here, you'll find out that the height of the ramp is approximately 0.12 meters. And that is your answer. This part is worth 3 points. So 1 point for saying that it goes up, 1 point for using the equation, and 1 point for getting the right answer. In the previous part, when you had to go through and try to figure out exactly how far it had gone, the distance traveled, this is worth 3 points. It was 1 point for just finding the area, just saying you're going to find the area under the curve, 1 point for finding it, and then 1 point for having that total distance of 5.5. And that is the end of the problem.